In the second project, you would be implementing a download accelerator over HTTP. The problem is the following. Assume that you have got a large object that you need to download from an HTTP server. So instead of having one client, one thread connecting to the server, issuing a get command to download the entire object, you're going to have the main thread issue a head command instead to the object and only get the length of this object, right? Let's say the length of this object is n. Then it's going to create some number of threads. In this example, I have I've illustrated that the main thread created 4 threads. Each thread would be responsible for downloading one portion of this object, and then of course the downloaded objects will be saved into the same common file. All right, so if the size of the object is n bytes, you would expect thread 1 to be downloading the first 1/4 of this object. The thread 2 would be downloading bytes from n over 4 to 2n over 4. And finally, thread 4 would be downloading the last 1/4 of this object. Let's now look at the actual messages that are being exchanged between the client and the server. Assume that we would like to download this object from www.textfiles.com. So the main thread would be issuing a head command. So let's do it. And this is what we get as the response. As you can see, what we get as the response when we issue the head command are the HTTP headers without the body. And the header line we are interested in is content length. That tells us the size of the object that we are trying to download, which in this case is 211,543. Now assume that the client is creating 4 worker threads. Each thread would be responsible for downloading 1/4 of this object. So the request that thread 1 would be sending is now a get request to the same object, but this time look at this header. It says, I would like to download the bytes from 0 to 52,885, which would be approximately 1/4 of this object. So if we send this, you're now going to see that the response we're getting is HTTP 1.1 206 partial content. And it tells us that the content length is 52,886. And this is the range of the bytes that's being sent in this message. And here is the actual message that's being sent from the server. So if we could, the second thread would obviously be, so let me copy and paste this thing. So to tell you what thread 2 would be downloading. So thread 2 would be doing the same thing, but it would be downloading now the bytes from 6 to twice this number. So twice this number would be something around, you have to do the computation, but I would expect it would be something like, a 103,664. Let's just, I've just made this up. I don't know what, the twice of that value would be, but something like this. So if we do this now, if I send this request, you're going to see that this is these are the bytes that I'm getting from the server. So bottom line, every thread that you're creating would be downloading one portion of this file, and then they will be all writing them into the same output file, and combining them to create the actual file that's being downloaded. So I have already implemented this, and I am going to run the application downloader.py. So if you look at the write-up, it says it needs to take 3 arguments. The first argument would be the number of threads, right? The second argument is the actual object URI of the object that we are trying to download, and the third argument would be the name of the local file where we are going to write the downloaded object to. So for example, let's say I would like to download this using 4 threads. This is the actual URI of the object. And then out.txt is the output file where I would like to write this file into. And in this case, I am downloading a different file. This is a bigger file. So this is the actual URI of the object, URL. and then out dot dot is where I would like to write this file. So in this example, I just made the number of threads to be 1. So the number of threads should be, you should be allowing the number of threads to be between 1 and 16. It cannot be less than 1. It cannot be bigger than 16. So let me just run this thing. And you can see that we downloaded the file using one thread in 1.35 seconds. And the way I am going, after downloading it, of course, we need to test whether we have actually downloaded the file correctly. So what I'm going to do is I'm going to use this file compare utility. So this is where we have, saved the file that we have downloaded using our application, and I have already downloaded it using Chrome. So I'm just going to compare them. And if your application is working correctly, the file compare should tell me that there are no differences between the file that your application or my application has downloaded and the one that Chrome has downloaded. So I'm just going to now increase the number of threads. So let me make the number of threads to be 4. And obviously, we can expect that it's going to take less time. As you can see, it's only taking 0.51 seconds. And as you can see that the first thread is downloading the bytes from 0 to 447K. The second thread is downloading the bytes from 447K to 894K, and so on and so forth. So I'm just going to do the same thing. I'm going to again compare just to see if using 4 threads we have downloaded it correctly. And yes, it's working correctly. So eventually I'm gonna let me make it. Let me increase the number of threads. So from 4 to we can go up to 16. So I can make any number like 13. Right? I can make it 13, and it should work. And I can make it 16. So eventually, let me make it 16. That's the largest number. And finally, compare what we've downloaded to the actual file. And we should always be getting there are no differences between the files that your application has downloaded and the actual file that I've downloaded using Chrome.